Good afternoon, all the students. How are you? I hope you all are blessed and fine. Now we are going to discuss about today's concept, that is electronic configuration. Yesterday we already discussed it. That is what is orbitals and what is the nature of orbitals, and somewhat the conceptual questions are also completed. Now we are going to discuss about there is electron configuration. With that, this lesson may complete. Now listen all the students, what is the electron configuration? And here we already discussed it. Whatever the electrons are there in atoms, okay, and they are in which place actually? Okay, they allotted in a which place, they are occupied in a which place. That will be given by the what? That will be only given by this our yes electronic configuration. The distribution of electrons among various orbitals. Okay, that is what we call about electron configuration. Okay, yes, it's a very important thing. All the students listen carefully here. There is a what? Suppose an electron is there. Okay, the electron is how we distributed. Which one it is in a which orbital may it is entered. That will be only given by our electronic configuration. Otherwise, in our atom there is 8 electrons are available, and we distributed these 8 electrons in a which orbit, depending on somewhat laws and other somewhat chemical properties. Okay, clear or not, all the students? Somewhat we don't know where it is actually exact position. We don't know. Okay, that is why we are applied somewhat Abbo principle, Moore's principle, Pauli exclusive principle, and somewhat experimental observations. Okay, now why? Because we get only probability. We not get a fixed thing. We get only probability of position of electron. Till now also we not get any particular idea. Physically, it is not possible to see electron. Just we are okay distributed theoretically only. That is only we are going to discuss in this particular concept. Okay, simple thing. What is electronic configuration? Distribution of electrons among the various orbitals depending on the various laws. Okay, and the principles. That is only called electron configuration. Okay, whatever the general form it is there for electronic configuration based on based on our quantum numbers, based on our quantum numbers. Here, like that, we are considered there is a number of electrons. Okay, clear or not? Here, NLX it is. Okay, simply we want to give the position for electron or a 1 electrons or a 2 electrons by using this general form only. Here, N is called, you know very well, principal quantum number. It is a called what? A principal quantum number, and it is a called what? Azimuthal quantum number. Azimuthal quantum number. Yes, and as well as this is the indicator what? Number of electrons in a present in a orbit. Got it or not? Yes, it is a L value depending on azimuthal quantum number. It is indicate orbital. It is indicate orbit. It is indicate what? It is indicate how many are there. Okay, how many electrons are there? Okay, clear or not? A simple thing, Nana. There it is. Suppose you are there in a class, in a school. Sorry, in a school it is there. Yes, your parent or otherwise any one of them may are coming for you. How they ask in a school? How they ask us, where is my kid? Okay, clear or not? Yes, how we answered here in the school it is correct. It is not a correct. It is not a correct. No. In the school there is so many classes are there. In the classes so many benches are there. Again, in the benches there is again positions are also there. Like that, we distributed our address. Simply the electron configuration indicate the address of each electron. Address of each electron. Okay, now where it is? In orbit, where it is? In a which orbit it is there? In which orbital it is there? In that orbital and a what position it is there? Okay, that all information is given by our electron configuration. Okay, clear or not? How we write it is, there is one, suppose there is a, and write like this, 1s1. What is the meaning of it? 1s1 means this electron, this one electron, whatever electron is there, that is in a first orbit, in s orbital it will be there. Okay, clear or not? It is orbital position. Okay, clear or not, all the students? Orbital position it is, and as well as it is the electron position. That is only we are considered here. Now there is first we are going to discuss about first 20 element electron configuration. How we are going to write here? Okay, now first 20 electron configurations. Everyone must and should write with me. Okay, now yes, first 20 electron configurations. Yes, one by one. Hydrogen. The first element is hydrogen here. Hydrogen electron configuration is the 1s2. Okay, now yes, and as well as it is the called electronic configuration. It is orbital level electronic configuration. 1s2 not 1s1. Orbital electronic configuration. It is the 1s. Okay, next up. As afterwards hydrogen, we recognize the helium. Helium atomic number is how much? 2. Okay, now there is available how many electrons are there? 2 electrons are there. That's why we written it is as a what? We written it is as a 1s2. Okay, now it is written as a what? 1s2. It is the 1s2. Now it is written as like that 1s2. This is also electronic configuration. It is orbital level representation. Okay, now yes. Every time no need to mention these boxes. This is enough. Electronic configuration is nothing, but only this is enough. Okay. And next, come to here. After helium, we have the what? Lithium. How many electrons are there? 3 electrons are there. Okay. Now 1s2. Next one, 2s1. Why? Because in a first orbit, no other orbitals are possible. Only s orbital is only possible. Got it or not? 1s2, 2s1. Okay, now how we written it is like this. This is the 2s started here. Okay, clear or not? Next, after the lithium, we have to go with the what? Beryllium. This is the what? 1s2. Next one, 2s2. 1s2. 2s2. What is atomic number of beryllium? 4. How many electrons are present in this? 4. The 4 electrons are distributed in s orbital and as well as the 2s orbital and as well as the 1s orbital. Okay. And next, there it is written as like this. Next, after beryllium, boron. Yes, boron. How we written it is 1s2, 2s2. Yes, completed. Now start with the one 2p1. 2p1. How we written it is like this. Next 2p started here. Got it? Got it or not? Next, afterwards, carbon. 1s2, 2s2, 2p2. There is the 2 electrons. There is the 2 electrons again. There is a 2p. Next, nitrogen. 1s2, 2s2, 2p3. Yes, write it. Next, I'm taking oxygen. oxygen. What is the electron number? 8. Okay, now what is the you have to write? 1 is 2, 2 is 2, 2p4. 1 is 2, 2 is 2, 2p4. Now it is also written as next after oxygen we have what? What we have after oxygen? Fluorine. 9 electrons are there. Na? It is written as 1s2, 2s2, 2p5. Yeah, next after this neon. 1s2, 2s2, 2p6. P6. Next after neon we have the sodium. 1s2, 2s2, 2p6, ps1. Got it or not? Again started. Third orbit is started. Why? Because second orbit highest capacity how much? 8 electrons. Okay, now the second orbit how many electrons are there? 8 electrons are already filled. First orbit highest electrons 2. Okay, clear or not? And now the next thing is how many are in third orbit? Third orbit, what is the number of electrons are present? Orbit. Okay, now that is a 2 into n square. Here n is equal to how much? 3. Totally 18 electrons. How many electron capacity is there? 18 electron capacity is there for the third orbit. Like that only in second orbit, na? 2 into 2 square. That is the 2 into 4, that is the 8 actually. Got it or not? 8 filled na up to here. Now we are going to sodium. One more it is. Okay? How we written it is like this. Yeah, it is a 3s1. These are the 2p, these are the 2s, this is the 1s. Now the 3s, it is a 1 electron is there in a 3s. Got it? Now there is, you have taken up to afterwards magnesium. 1s2, 2s2, 2p6, 3s2. Yeah, this is the magnesium 12th one. We completed all the students up to here past. If possible, you try for coming things also magnesium 13. This number should be equal to its atomic number. Whatever the electron number is there, that is equal to should be atomic number. It is equal to 12, 2, 2, 2, 6, 2. Okay, not 12 it is like that. Complete it. Yes, next after this. After that, magnesium, we have aluminium. Okay, aluminium, anyone? Ready? 1s2, 2s2. Okay, na? 2p6, 3s2. Okay, na? 3p1. Okay, clear or not, all the students? 1s2, 2s2, 2p6, 3s2, 3p1. And there you have to write the remaining. This is what is the nature of it. Okay, clear or not? Yes, you feel that is in orbitals. Okay, na? In orbital level manner. Next what we have after aluminium. Okay, na? After aluminium, there is what? Silicon. Okay, clear or not, all the students? Silicon it is. Okay, na? SI. Now it will become what? 1s2, 2s2, 2p6, 3s2, 3p2. And afterwards phosphorus. Okay, clear or not, all the students? The next it is written as 1s2, 2s2, 2p6, 3s2, s 3p6. Sorry, 3p3. Got it? Next, after this sulfur. Okay, na? That is become what? 1s2, 2s2, 2p6, 3s2, 3p4. Got it or not? After this, we have after the sulfur we have okay na? Yes, chlorine. Okay, 1s2, 2s2, 2p6, 3s2, 3p5. Got it or not? Yes, next after this chlorine, we have the what actually? Argon. Next one is argon. 1s2, 2s2, okay, 2p6, 3s2, 3p6. Okay, now yes, completed. The p orbital also completed now. Next, how will get it is next argon. Afterwards, we have potassium. Okay, clear or not, all the students? Potassium. It is written as what? 1s2, 2s2, 2p6, 3s2, 3p6. So many are. Next, we are going with the what? 3D or 4s? 4s. Okay, now why we are not go with the 3D? Why we are go with the 4s? Tell me. In the 3D and 4s, which are contain more energy. 4s is a contain less energy, it is a contain more energy. First, it will be contain low N plus L value. Which is a contain low N plus L value? 4s only. What is the N plus L value for the 3D? Yes, it is written as 3 plus 2. Okay, now d orbital na N value become 2. Now 4 plus 0. S orbital L value how much? 0. That's why it is not enter into 3D orbital. Electron enter into where? 4th orbit. That is become 4s1. Okay, clear or not, others? Next, after this, okay, now calcium 1s2, 2s2, 2p6, 3s2, 3p6. Next, what we are doing is that 4s2. After 4s, it's started again 3D, not a 4p again. It is for a 21 element. What is that? What is the electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Why? Because 3d. Why we not? It is a 4p. Once check it. 3d and as well as the 4p, which contain NPSL value more here. Both are same. Okay, now 3 plus 2, 4 plus 1. Both are 5 only. But then why we are going with the not 4p? Why we going with the 3d? Yes, yes. At that time, what we consider N value. Okay, which is the lowest N value is there. Electron enter into first the lowest N value when N plus S, N plus L is a same. Okay, clear or not on this? That is only we are considering. Okay. Yes. Write down up to here, up to 20 elements. You should know what is electronic configuration. Okay. Now everyone must and should by heart or otherwise keep in your mind the distribution of electron. You should know. Okay. Listen carefully. First, for every orbit, two electrons are there individually. S orbital contain 2 electrons. P orbital contains 6 electrons. In every, yesterday we have discussed, every degenerate orbital contains two electrons. Okay, now, and first you have to know for one orbit how many electrons are there. Okay, now, for first orbit 2 electrons, second orbit 8 electrons, third orbit 18 electrons, the fourth orbit 32 electrons. Okay, now, that much of electron. First it is filled by the first orbit, second it is filled by the second orbit totally, third orbit, but third orbit is not filled based on electrons. Okay, now, yes, why? Because again there is energy is also main role played here. Okay, now, which is a contain less energy. In that there is the first electron enter, then next it will be enter the highest energy levels. Okay, clear or not? You are first studied first class or 10th class? First studied first class, then after 10th class, na? Like that only. First electron enter into lowest energy, then after highest energy. How to we are consider energy? By Upto principle. Okay, now, which are contain low N plus L value, that is a called low energy. Which are contain high N plus L value, that is a contain high energy. In case in the filling of the orbit, suppose the third orbit is not a filled totally, but a fourth orbit is a contain a less orbital energy. Yes, it is selected that orbital only, not entered into the orbit first. First priority orbital only. Which orbital contain low value, low N plus L value, electron first filled in that orbital. Got it? I hope you got it. Yeah. Also, students, there is a just please write it, and as well as up to 20 elements you have to write it. If possible, you try for the 30th element also. Okay, but when you cross the 20 elements, the scenario of electron configuration again changes. Okay, what the changes are there? Once we have to go discuss now. Okay, now first to complete up to calcium. Yeah, I hope you got it. It is the next some electronic configuration are not exemption actually for this process. As normally what we are doing here in the process of writing electronic configuration, yeah, we take a number of electrons and it is distributed by the S one orbit to the another orbit, one orbital to the another orbit directly. Okay, clear or not? But sometimes there is we not follow the same thing. Okay, once check it here now. There is a totally how many electrons are what is the 15 electrons are there? These 15 electrons are on the order we filled now. There is a p orbital compulsory after 6 only we are entering into the yes. There is a next orbital. S orbital must and should be taken 2. But some particular elements are not a contain electronic configuration as in the same manner what we written here. One more thing, it is also there. What is that thing? You know, suppose you take a chromium. Atomic number of a chromium is 24. Okay, na? Chromium atomic number is okay, na? 24 it is. Okay, it is a contain one different electronic configuration. Okay, what is that? It is a contain different electronic configuration. What that electronic configuration, you know, as tell me in case your 24 electrons are there, you generally what we written? Yeah, like this. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, okay, na 3d4. Like that only or not? One second. 1, 2, 4, 6, 10, 12, 18, 20, 24. Got it? Got it? But it is not like that actually. Actual correct electronic configuration for a chromium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, not it is 4s1 and as well as the 3d5. We write like that. Okay, why it is like that? Actually, the manner we have to write in this form only. All the above principle, Pauli exclusive principle, generally whatever the remaining 20 we written now, everything is followed this one only. But again, there is a one more new rule is came for us. Okay, when there is a number of electrons are like that available, okay, half filled or a full filled orbitals are very energetic, and it is a stabilized atom. Okay, clear or not? It is a more stable atom in case like that it is available. That is why we retain chromium and as well as the copper also. Copper atomic number is a 29. Okay, how we written generally? Tell me. There is a 1s2, 2s2, s2p6, 3s2, 3p6, 4s2, 3d9. Okay, clear or not? 3d9. Why? Because d orbital maximum capacity how much? 10. Okay, now d orbital maximum capacity how much? 10. Why? Because it is a contain 5 degenerate orbitals. dxy, dy, z. Yesterday we have discussed. D orbital maximum capacity is a 10. F orbital maximum capacity is a 14. P orbital maximum capacity is a 6. Okay, now we already discussed. Now it is not a correct actually. Which one is the correct then? Yeah, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. Okay, clear? It is a correct. It is a correct. It is a wrong. Why? You know, there is a one right orbital. Okay, electronic configuration. How you write it is orbital electronic configuration like that it is. Here it is a what? 1s2, 2s2, 2p6, 3s2, 3p6. Come to the 4s1, 3d5, whatever I have written here. Okay, how it looks one second. 4s1. Okay, 4s1 it is. 4s1. Next what here? 3d5. Yeah. What you observed in S maximum capacity how much? 2 electrons. Half of it is 1 na? 2 by 2 it is a 1 na? Okay na? 1 it is there. And here how many it is there? 5 it is there. Maximum capacity is how much? 10. It is called half filled or not? Half filled or not it is? It is also half filled or not? Yeah, half filled things are more stable. That's why we written, okay, for a chromium like this electronic configuration. S4s1, 3d5. Actually, the general manner it becomes 4s2, 3d4. but it is not like that. For our stability purpose, we written okay 4s1 3d5. Copper also like that. The copper last what we written 4s1 3d10 we written. Actually, what we get 4s1 3d9 we get, but we written in a copper 4s1 3d10 we written. Okay, one second, how we written it is? Yeah, it is a half filled. It is become full filled. Understood or not understood? Half filled or a full filled okay, orbitals are contain stability, more stability. That atom becomes stable one. That's why the configuration we may expect in this form. Okay, like this, somewhat other elements are also there. Okay, now yes, it is not a possible for all the things. It is a possible for everything. No, it is not a possible. Any one of these it is a possible like that. No, it is not a possible. The distribution is not a possible for all the things like that. Okay, clear or not on this? Yes, that is why where it is a possible, you have to should compulsory write in this format only. This is another law for electronic configuration. Okay, now writing purpose. What is the thing? What is the statement of this? Either fulfilled electrons, fulfilled orbital electrons, or otherwise half-filled electrons orbitals are contain a more stability, That's why the electronic configuration have right in that form only, either in half-filled orbital or a full-filled orbital base. In a copper, there is a totally 10 filled. One is half-filled. In this one, there is a 2 or half-filled. That's why there it will become more stable. This is only about our electron configuration. Okay, now hope you understood all the students. Okay, now just only one thing is the remain. Okay, now practice sheets are remain. Okay, once you do it, the practice sheets. Okay, now if you have any doubts or important things are there, next week first class I want to complete it. Okay, now with this first unit of chemistry completed. Okay, next we are going with again physics classes. Okay, very interesting things next week, kinematics. Okay, now till now physics only we completed second unit, that is vectors and scalars. Okay, now yes, vector product it will be completed. Scalar product of vector also completed. Next we are going further as pure physics concept, that is a kinematics. Okay, now already we have somewhat touched with the topic. Yes, we are going with that concept, kinematics. Okay, thank you one and all.